I'm going to bet that I'm going to have to reboot at some point. Let's see how far we can go here.
Okay.
All right. Have you done any of these, or do we need to start from?
I haven't even. I just got it today, so.
Okay. Let's take number 1. We know it's a prism just because the title of the section is volumes of prisms and cylinders. Actually, a cylinder is a prism. So the title really should be volume of prisms.
Okay.
Okay. Why is number 1 a prism?
Because when you cut it in half, you'll still see a rectangle.
Not a rectangle.
Oh, a triangle?
Yeah. In other words, see this top face here?
Yeah. And
that
the
is the same as the bottom face.
Yeah.
Which has dimensions of 12 inches by 9 inches, and it's a right triangle. In other words, if I draw that bottom face, it looks like this.
Yeah.
And the top face is the same way.
Yeah.
They've labeled it funny to make it look like it maybe isn't a prism, because they tell you on the top face that this is 15.
Yeah.
Well, okay, that is a 3, 4, 5 triangle. Notice. It's a multiple of 3, 3, 4, 5 triangle, but it's, when I say 3, 4, 5 triangle, you know what I mean. In other words, it's either a 3, 4, 5 or a multiple of a 3, 4, 5. Yeah. All right. So, what's the volume of this thing going to be?
So it's just 12 times 8, base times height, and then times 9.
Remember that the volume of a prism is the area of the base times the height.
Okay.
What's the area of this triangle? What's the general formula for the area of a triangle?
Is it 1/2 base times height?
Okay. What's the base? What's that translate into here? 1/2. What's the base of this triangle?
6.
Okay, it's 12. You already applied the 1/2. Okay. Times the height of 9.
Yeah.
So that's 6 times 9, 54.
Yeah.
So this has an area of 54. So in place of the area of the base, I'm going to put 54, so the volume is going to be 54 times 8. That's the height. Okay. In other words, you have to, when you're looking at these prisms, you have to look through where you're going to slice it. In other words, I'm going to slice it horizontally here.
Okay.
No matter where I slice it horizontally, I see this triangle.
Yeah.
Okay. If I slice it in a different plane, in other words, if this was a piece of cheese and I would take a knife and slice it from the top down, I wouldn't see this rectangle everywhere. I would see a smaller and smaller rectangle. So it's not a prism because of this face here. It's a prism because of this triangle here is the same as the bottom triangle.
Yeah.
All right. Let's look at number 2. Notice why number 2 is a prism. In other words, on number 2, I'm going to slice it right in this plane.
Yeah.
And no matter where I slice it, I see this little rectangle that's 4 miles by 6 miles. Is that what MI means?
I think so.
Okay. So what's the volume of number 2?
So
Number 2 also fits the definition of what I call a rectangular brick. It's where the bases are rectangles.
Yeah.
And it has some length. In other words, that thing right there could be a brick.
Yeah.
So remember what the general formula is? It's the area of the base times the depth. What's the area of the base?
Is it 2 times 15, 30?
No, hold on. Well, with a brick, you can actually choose any of the faces as your base.
Okay.
Okay? In other words, it doesn't matter where I slice this thing. I'm going to see this face. This is actually a prism from 3 different planes. This rectangle is the same as this rectangle. This rectangle is the same as that rectangle. And then the top rectangle is the same as the bottom rectangle. So when you're dealing with what I call a rectangular brick, it's just the 3 dimensions times one another. In other words, let's say it's a prism because this base here is the same as this base up top. Okay, well the area of the base is 4 times 6 times 15.
All right.
In other words, I took the area of the base times its thickness.
Yeah.
Well, I also could have taken 6 times 15 as the base and multiplied it by 4. A brick is particularly different than most prisms in that you can choose. In other words, this first problem here only had one base that had an opposite equal base, and that was the triangle. Different than the brick. But it still comes down to the area of the base times the thickness. Okay?
Okay.
So number 3. What is the base?
20.
Now, by that question, I mean, what is the base one of these rectangles, or is it the Pentagon?
Is it just 8.3?
Hold on. Is it one of the rectangles, or is it the Pentagon?
Is it the Pentagon?
Exactly. In other words, the Pentagon is the same on both ends.
Yeah.
Okay? That means this is a prism. So we have to find what? The area of the Pentagon times this height.
Yeah.
Okay? The area of the Pentagon. We did this last week.
I think so.
1/2 S times A times N. Remember 1/2 san?
Yeah.
Okay? So, what's S?
I don't remember.
Well, what is the side length?
12.
Okay? That's what S means. It's a regular pentagon, meaning all sides are the same, and it's telling you they're 12.
Okay.
That's S. What's A? The apothem.
The apothem.
What is it in this case?
8.3.
Yeah, from that diagram, they're drawing from the center of the pentagon perpendicularly to one of the sides. That's how you measure the apothem.
Okay.
How many sides do we have?
1, 2, 5.
And what's in other words, so this represents the area of one face, of one base, actually.
Oh.
So we have to multiply that by what? In other words, for volume, we want the area of the base times the only other dimension. What is it?
17.
In other words, the thickness of this thing.
Yeah.
This would be a prism, regardless of whether this 17 was 17 or 24 or 112. It would still be a prism. It would just be a thicker hat box or whatever this thing is. So you need to turn this in with answers?
Yeah.
You have a calculator?
Yeah.
Let's come up with this number then.
Alright. So, what should I do?
Well, you need to come up with the area of the base and then multiply that by 17. And the area of the base is this thing here that I've put.
Alright. So 1/2, so 6 times 4.15 times 3 times 2.5.
Where'd you get 4.15?
From the 8.3.
Well, if you're going to take half of 12 to get 6,
Yeah.
you don't want to apply that half again.
Oh, you don't?
No.
Okay.
That's an important concept. Let's review that. If I'm multiplying A times B times C times D, I multiply A times B, take that result, multiply it by C, take that result, multiply it by D. I don't multiply A times B and then remultiply A times C and then remultiply A times D and then multiply B times C times D. It's not the way I do it.
Yeah.
Okay? So, when you're multiplying four things together, you just, in your calculator, you say 0.5 times 12 times 8.3 times 5. What do you get for that?
249.
Okay, and now multiply that by 17.
$4,232.
That's it. There's your answer. What are the units?
Yards.
Cubic yards.
Oh, yards cubed.
Yards cubed. Do you see why?
Yeah.
In other words, when we're measuring in one direction only, it's yards. The length of that side of that pentagon is in yards. If I'm measuring area, the area of that base, this quantity here, is in square yards. It's in yards squared because I'm multiplying yards times yards. And that's a two-dimensional shape. Well, when we're talking volume, we're talking three-dimensional. So volume is always going to be measured in cubic whatever the thing is. In this case, cubic yards. In the first case, it was cubic miles. All right, let's look at 4. Now, this actually fits the definition of what I call a rectangular brick.
Okay.
In other words, it's a solid where all angles are right angles.
Yeah.
I don't care what the face is. I don't have to identify the base that is equal to its opposite. This one is equal to its opposite, this one's equal to its opposite, and that top one's equal to its opposite. So the only thing I need to know about a rectangular brick are its 3 dimensions.
Okay.
What are they here?
18, 3, and 17.
That's it. Multiply those 3 together. What do you come up with?
Is that times 0.5?
No. There's no half.
Oh.
In other words, regardless of which base we would be looking at, its area would be base times height. We're not dealing with a triangle here. We're dealing with nothing but rectangles. Okay. So there's no half. It's the 3. When I say rectangular brick, it's the 3 dimensions multiplied together. 3 times 17 times 18.
Equals 918.
Okay. I'm not checking you, so I'm going to assume that your calculator... What calculator do you use?
The TI-84.
Okay, I do happen to have that. I have it here. Have I ever shown you this?
Yeah.
Yeah. So if you ever have any questions about how to use this calculator, I can certainly help you because I can bring it up.
All right.
Okay? Typically, I'm not going to do that just because I'm going to count that you know how to use that calculator and you'll come up with the right answer.
Yeah.
Okay, so number 5.
Okay.
What's its volume? And incidentally, on number 4, that was cubic centimeters.
Yeah.
Number 5, what's its volume?
Wait, so is this like a rectangular brick again?
It is. All angles are right angles.
Okay.
And we have nothing but rectangles or squares.
Okay. So the volume is 1,700
cubic miles. Make sure you put the units on it. She's liable to take off if you don't.
Yeah.
Okay. Number 6.
All right.
Number 6 is no longer a rectangular brick.
Yeah. So is that like 1/2 center?
Okay. So first of all, the volume equals the area of the base times the height. Always with prisms. Okay. So what's the area of the base? I mean, give me the general formula.
So 1/2. So it's
1/2
side. Yeah.
Okay. What's the side length?
10 meters.
What's the apothem?
8.7.
And how many sides are there?
1, 2, 3, 6.
Okay. So what's the area of the base? Now you don't necessarily have to, I don't have to come up with the area of the base. I could just multiply it by its height, which is what?
261.
Well, is that after you multiply it by its height?
No.
Okay, what's its height?
14.
Okay, now multiply that by 14.
3,654.
Cubic M.
Cubic
M's. M could be meters, miles, maybe something else, I don't know. Alright, let's look at 7. When I first looked at 7, I didn't think it was a prism.
Okay.
Because it looked like I don't know what this object would be, where the base, this bottom base that it's sitting on, looks smaller than this top base. Right? And it is. It's 10 inches, and this top base is 20 inches by 17 inches.
Yeah. That's weird.
So it's not a prism from the top to bottom.
Yeah.
If I were to slice this horizontally, I'm not going to see the same rectangle. However, and it's difficult to tell this from the drawing, but if I consider this side here that I'm pointing out to be the base, then it does look uniform throughout this distance here.
Yeah.
So it is a prism, and this is the base. So the first thing we have to do is figure out the area of that base. So let's draw a triangle, and that base is a trapezoid. In other words, if I draw this base in 2 dimensions, it looks like this. What's going on? Well, I still think I'm going to have to reboot before we finished. This is as far as I've ever gotten on the thing. When I've had problems, normally I can't go anywhere, and that's the way it is right now. Julian, give me 5 minutes. I'll reboot and I'll be back to you. I'll have to resend you a meeting ID number.
Okay.
All right? Sorry, I'll talk to you in a moment.
That's fine.
Can't even close it out without doing Control-Alt-Delete.